Hello, everyone. Thank you so much for joining. This is Brandon Stifler. I'm a software product manager for Beckhoff Automation USA. So we here at the PM team and the marketing team as well at Beckhoff USA are super excited to be rolling out these monthly webinar Wednesdays over the course of the next several months. We're going to be discussing exciting new products, technologies from Beckhoff. And some of these sessions are going to be sort of focused on a particular product or product offering, while others, like today's, are kind of a broader industry topic with emphasis on relevant Beckhoff technologies, obviously. But if any of your team members are interested in the latest and greatest with automation technology, make sure to keep an eye out for future sessions and get yourself registered. So currently we have the following future sessions scheduled. We have Advanced Motion Control on November 20th, Test and Measurement December 11th, and Beckhoff's XTS system on January 22nd. But without further ado, let's kick off this inaugural session here, Software Development Tools and TwinCAT. All right, so over the past several years, we've been having more and more conversations about software development concepts, tools, methodologies, and where they fit in our world of automation. Right? Terminology like DevOps, source control, automated testing, these things are ubiquitous to software engineers, but often considered impractical, incompatible, or altogether foreign in the realm of controls engineering. So why might that be? I think it's no secret that the automation industry is a bit reluctant to change, right? Evolving at a relatively much slower pace than other tech disciplines. But I think this conservative approach actually makes a lot of sense when we consider kind of the critical nature of industrial processes on top of all the other considerations involved in controls engineering. Right, we have mechanical and electrical design, safety, communications, compliance, maintenance, and that's just to name a few. Yet despite all this, I think delivering functional code, functional software remains a primary goal for all of us automation engineers. So in this regard, I think we have a lot to benefit from catching up with the rest of the software industry. So our automation systems are going to continue to grow in complexity, and we as engineers are going to be expected to produce higher quality, more data-driven, more reusable solutions. So whether we like it or not, we're going to continue to see that gap between OT and IT, right, between PLC programming and software programming narrow. So let's put aside the differences and instead spend some time talking about the tools and strategies that benefit the shared development experience for both domains. So what I'll be doing today is contextualizing the software development lifecycle here in conjunction with Beckhoff's TwinCAT engineering software. So I think many of you are going to be surprised to learn that our technology and our tools have already been accommodating many of these practices for several years now. So let's learn how TwinCAT can enable you or your organization to effectively apply these principles with your engineering process. So starting with phase one, design and planning. Now, this first phase can mean a lot of different things to a lot of different people, right? So for the sake of time, we're skipping like the very high level planning. We're assuming we have a business case. We have some semblance of a specification for whatever product or solution we're developing. Right, we're going to fast forward a little bit to kind of right before the rubber hits the road, and we need to start building something. So because controls engineers typically wear a lot of hats, design can mean a lot of different things too, or design, planning, right? We might think of electrical design, speccing hardware, maybe even some like high-level whiteboarding to hash out a system architecture. Where on the software side, design a lot of times means like visualizing the behaviors or the relationships between our components or our software modules. Maybe we're identifying some of the data structures we'll need or organizing how we expect to exchange information with external systems. But these should all sound familiar or relevant regardless of the programming language or the platform you're using, right? These are automation and software skills alike. So we are in the design planning stage. Maybe we have a requirements document. We want to start designing our software components. Where might we start? Luckily, TwinCAT has a few tools that can aid in this piece. So perhaps some of you have familiarity with UML, or Unified Modeling Language. Thanks to the IEC standardized support for object-oriented programming, and we're going to be touching on that a lot throughout this presentation. But with UML, we can kind of conceptualize the components of our system as objects or classes, which we can then visually define using UML class diagrams. So furthermore, we can outline these states and transitions of our process using UML state diagrams. So there's kind of two pieces here. They're a little bit different, but related. But let's take a look at what that might look like in action. So here is a short video just demonstrating the creation of a UML class diagram in TwinCAT. And the real convenient thing is that we're doing this right within Beckhoff's unified development, unified engineering environment. So this is the same place we're going to configure our I/O, program our PLC, maybe even write our safety logic, configure our drives. Everything is right within this environment. But the best part is, and maybe you can see this, let me get my laser pointer here, but as I drop in the modules in the diagram here, and I'm just plopping in some interfaces, doing some properties and some methods, you can see it's actually populating over here in the code itself. So that goes for, again, the properties or the data behind our objects, the methods or the behavior, and the relationships. So as we create those relationships, like implementing interfaces, that all gets tied in over here on the code side as well. So we, of course, need to go through and implement the control logic, right? We're doing just a cylinder as an example here. This diagram is not going to actually actuate our cylinder for us, but we've given ourselves a bit of a head start. We've given ourselves an easily readable visual representation of the modules and in a standardized format. So maybe someone else coming in, joining the team that's familiar with this interface, they'll be able to kind of get up and running much quicker. It's also worth mentioning that the relationship between the code over here and the diagram is bidirectional. So like we did all the generation here, we built out the diagram first and watched kind of the code fill in. You could do it the other way as well. You can develop those modules over here and then generate a UML diagram from the code. So moving on, and here's a quick demo of the state diagram. Here we already have the process outlined, but the difference where the UML class diagram was just kind of a nice templating tool, the state diagram is actually a usable kind of piece of code. So we can actually take this online. That's what I'm doing here. I'm going online with this project. You can see my active state is highlighted in blue. I can kind of jump through the states and see it change kind of in real time. So this state diagram is actually a usable state machine that logically outlines and runs your process. Yeah, and you can just see I kind of drilled into the logic within the state or substates therein. So yeah, just a nice sort of templating tool that actually turns into a usable state machine, usable code. So as always, and I want to touch on this early, more technical documentation is available regarding this UML editor and all other Beckhoff products on our Infosys page. So in addition to documentation, you can typically find detailed examples, frequently asked questions, troubleshooting tips, even some sample code. But that wraps up our design phase. And now we're going over to the implement phase. So perhaps you're through planning. We're jumping into implementation. We've already hinted at the object-oriented capabilities of TwinCAT. And if you started with a UML diagram like previously illustrated, you're likely headed in the right direction already. But let's kind of dive into that a little bit more, or the object-oriented programming conversation, and learn the benefits and why it's important. So traditionally, PLC programmers have opted to structure their code in a very typical sort of imperative manner, right? We read the inputs, set the outputs. We're going kind of line by line or rung by rung. If you're into that sort of thing, no shame. But while there's nothing functionally wrong with this approach, it can be limiting in many ways. We're often relying on a bunch of kind of shared or global state, and our subroutines usually end up super long, maybe a little disorganized, unruly. Where conversely, with an object-oriented approach, we can use encapsulation to make our modules more portable, readable, and reusable, and maybe even implement some abstractions to extend module definitions and allow for flexible, future-proof architecture. So these are kind of the core aspects of OOP and what makes it so valuable. But for a quick application example, we can look at sort of just basic point-to-point motion control. So we're using these standard PLC Open MC blocks here. And these should be familiar to anyone that's done motion control programming in just about any platform. But you can see even for a simple path, we have a bunch of different states. We have a bunch of several function blocks, a relatively complex sequence. And while all these details are absolutely necessary to actually get the motor spinning, right? Ideally, we can define this logic a single time and encapsulate it into a flexible, reusable module. So on top of that, we've improved the readability as well, right? The details of our Axis implementation, right? What we just saw, that state machine, they're not important to the overarching scope of the system logic here. So consumers of this code, whether they're building on it or coming in and just reading it later on, they're going to want a friendly, idiomatic interface describing the code's behavior. So yeah, those are the primary advantages of adopting object-oriented programming. And it's totally a rabbit hole. We're really just scratching the surface here. We can get into, all the good stuff like polymorphism, dependency injection, design patterns, and these are all things that we can accomplish within TwinCAT, within these IAC languages. But it's probably best kept to another webinar. We kind of got to stay on track, and we're going to get into another software fundamental, another piece of the implement stage that I believe should have full-scale 100% adoption in the automation industry, but it somehow still doesn't. And that would be source control. So believe it or not, I still do not see widespread institutional adoption of source control in the automation industry. So, I mean, it's much better than it was even a few years ago, but in my opinion, not nearly where it should be. And my perspective is actually a little biased too, because I'm dealing with mostly Beckhoff users who are probably a little bit more likely to have adopted this technology than others. But anyways, let's get into it. So as we're developing our machines, right, we're working with our team, we're in that implement stage. It's often a very iterative process, right? The scope of the application is subject to change over time, and then so is our code. So we've all been here, right? Maybe we have a bunch of different versions of the project in a directory. We have maybe some version names. We have varying levels of descriptiveness, and maybe even a little date or timestamp associated with some or other files. But just a reminder, this is not a great place to be. We're not totally sure which file is the latest. We don't know exactly who made the latest change or where it is, whether there's a new copy somewhere on someone else's machine or out here on some thumb drive, right? It's a difficult way to manage a project. It's a difficult way to collaborate with a team. What if I need to roll back to a previous version before or during some specific change? Like, where do I even start doing that? Is that even captured in any of these versions? It's also quite dangerous, right? I can always just upload the latest and greatest from the controller, right? Well, no, not always. I think many of us have been bit there. So what's the solution, right? It's there. Better question, why aren't we using it? Why haven't we been? I think we're all aware of these source control or these version control systems. I think we definitely understand the value, but maybe we felt our platform or our tools were incompatible. Maybe our programs and configurations were always saved in some proprietary binary file format that doesn't play nice with the existing version control systems. Maybe a vendor or some third party even offers a solution, but it's in the form of a dedicated closed-off product. Maybe it only works with certain platforms, or maybe it has associated costs or other barriers to entry. In my opinion, this is a hard pill to swallow when such mature and robust tooling already exists and our software friends have been using it all along, right? On top of that, it's totally open source and free to use. So when your team can work with a technology like Git, your project files have a single central source of truth. You have a snapshot for every single change and who made it, basically an audit trail of your program over time. You have contributor comments that explain what exactly has changed in each commit or what that contributor's mindset was. And even like tooling for visual line-by-line comparisons for every single modification over time. These are really just the basics too. These are top-level advantages of using source control. On top of this, there's sophisticated branching and merging technologies, or capabilities rather, for things like isolating different features or variations of the project, deriving new versions from old ones, and just so much more. So again, we're going to illustrate a quick video here of seeing this in action and what it looks like in the TwinCAT development environment. So being based in Visual Studio, the Visual Studio shell, a lot of the work is already done for us. But here I am simply cloning a repository, and this one's just from my personal GitHub account. But this particular solution contains both a PLC and an HMI project. So I'm going to pull that down from the remote repository, so it's on my local system. And then all the code and configuration files for both projects are totally text-based. So they're easily tracked by Git or any other version control system. This is also true for the graphical languages as well, right? Not just structured text. Yes, there is some wrapping XML in these POU types, but thanks to our built-in project compare tool, you can have a clean view of the diffs, the differences between the current modifications and what's in source control. And ladder and function block diagram changes are just as easily tracked and compared as something like structured text. So you're going to see I'm going to open up a POU, my main POU here. I'm just going to add some things, add a comment, change a value in an add operation down here. But you're going to see the development environment sort of recognize and acknowledge those changes. I have a Git changes window that I can see over here. And I'm just going to right click on this and I'm going to say compare with unmodified. So compare the changes that I just made with what's in source control. And you can see I have this nice side-by-side view. I have the lines that with the changes in them are highlighted. So you can see exactly what has changed. And I'm just going to do the same thing over here with an HMI page as well. So you can see that's like a .content file type. But there's no secret sauce, there's no binary format. This is just a markup file, right? Our HMI is all web-based, so it's just HTML. So I delete that object from the screen. I save the file. Again, source control picks up on that. It says, hey, you have a change to this file. There it is. And here through the interface, I'm just going to undo that change. So it is saved to the disk, but source control has the previous version. It just reloads it, and there's my button right where I left it. So, and then the last thing I'm going to do here is I'm going to commit and push the changes to that main POU that I made, just so you can kind of see the full integration here. And then we're going to go back and take a look at that file and see sort of the audit trail or see the changes to that file over time. So I could just right click on it. I have a little Git submenu, and I could say View History. And there's all the contributions related to that file. I have a unique ID for that commit. I have the author of the changes. I have a date and a timestamp for when it was made. So as you can see, these native source control compatibility right within the IDE and this nice interface for dealing with it is just super crucial and very powerful. So finally, to wrap up the implement stage, I'm just going to touch on a couple kind of additional ancillary or quality of life tools. These are also right within the development environment. They're part of TwinCAT. But first we have our static analysis tool, which allows you to enforce code quality standardization amongst your team. So for instance, you could choose from this list of dozens of preset rules, like catching unused variables or return values, multiple output rights, assignments and conditional statements, stuff like that, right? None of which will prevent your code from compiling, but might introduce unwanted behavior or readability issues. You can also specify custom naming conventions. So this would promote consistent prefixing amongst your team, right? In this case, we're saying all floating point numbers, reals or L reals, I want to start with a lowercase f. And you can see the compiler kind of catches on that stuff. So it's basically a fancy linter for your PLC compiler. So if you're familiar with what a linter is, and then with the added benefit of it provides useful metrics for your programs or your POUs as well, things like function stack size, the number of times it's called, stuff like that. If that's not enough, finally we have the PLC profiler as well, which provides a visualization of the POU call tree and just even further benchmarking metrics like program and function execution time, cycle utilization. So just a really useful kind of troubleshooting tool if you have code that you think might be inefficient, if you're getting watchdog expirations or cycle overruns. You can use this tool to really pinpoint kind of the offending block of code that's causing that. And then last but definitely not least, we have a document generation tool. So I think documentation in general tends to be a sore subject with many engineers, right, myself included. It's not the first thing we all want to be spending our time on, but it's obviously critical to any application. So TwinCAT's document generator allows you to generate program documentation just by using special annotations right within the code. So you can see I open up a project here, and I'm just using a special syntax, a comment syntax with little embedded HTML tags. You can even have image tags in there that DocGen tool picks up on. And then when I go to actually generate the documentation, I'll just pause it here. You can see I have multiple output formats to choose from, like HTML or PDF. I have a style sheet file that I choose, so I have full customization over what the generated document is going to look or feel like. So I just output that and then open it up. I elected for HTML, so it just opens as a web page. But you can see I have a table of contents here with navigable links into all my code modules. I have sort of a diagram, a UML diagram that's generated. I have the image that was embedded. I have all my program locals, my properties and methods. And that UML diagram is navigable links as well, so I could sort of drill through my dependency chain there. So you have this means of documenting your program that provides a standardized but customizable format. It's embedded right in your code, so it's tracked with version control because we're all using that, right? And you could document without having to leave the development environment. So just tons of advantages there over that dusty Word doc template that we're all used to using, right? But that just about wraps up the implement stage. And I'm guessing there were several folks here that have some level of familiarity with a lot of the concepts or the tech that I talked about in this stage. But hopefully there were at least a handful of you that learned something new as well, maybe a new capability. So now we're making our way into test and deploy. And I've grouped these two together because from a Beckhoff perspective, a lot of the same technologies are relevant to both stages. That being said, this is also where things start to get really interesting, I think, and where I think we really separate ourselves from our industry friends. So, excuse me. It's also going to start to close the loop on the whole DevOps conversation and where TwinCAT fits. So we've touched on how the TwinCAT IDE is based in Visual Studio Shell. And apart from the benefits we've already explored, like the great source control integration, the single environment for all programming, all configuration, Visual Studio also offers a very extensible automation API. And this is a huge part of what has afforded us the great DevOps capabilities we have. So on top of that, Beckhoff has been able to build our own interface to facilitate automating TwinCAT specific actions. So what this means is that virtually every task that you can complete as a user navigating the interface, with a keyboard and mouse, can now be done programmatically. So we can open a project, create a route, download to the PLC, and everything in between, right? So code generation, like dropping in a POU from scratch, from a template, configuring I/O terminals, linking I/O with program variables, anything you would manually do, and with very few exceptions. There's also multiple programming interfaces you can use to leverage this automation API. So this can be something built into like a full-fledged .NET application, or even just a simple little PowerShell script to open and build the project. So where does that fit in the whole software development lifecycle? Well, if we take, for instance, that simple PowerShell build script, and this one is actually a syntactically accurate one, when we use that in conjunction with source control and with the continuous integration tooling, for example, Jenkins or Azure DevOps, and don't worry if those are totally new to you, I will elaborate. But we've now provided a mechanism for automating the build and test process of our application. So we can trigger the execution of this script, which will generate the build output of our project, right? For TwinCAT project, that's just a boot folder. And being that we're PC-based controls, we now have a number of options to then distribute or deploy that runtime or that output as a runtime to the appropriate edge devices. So it's okay if you're a little confused. I know there's a lot going on there, but I can kind of start from the top, cover the whole workflow, what that might look like, and kind of all the components involved. So as we know, it starts with a team member, right? We make a change to the code base, and since you've sat through my previous section on the implement stage, you're all already gone through and adopted source control, right? We have a remote repository, and those code changes get pushed to that remote repository. The next piece is that CI, or continuous integration tooling. And I threw some names out there before: Jenkins, Azure DevOps. They all do very similar things, which is kind of sit in the middle. Get my laser pointer back. Sit in the middle and kind of delegate the whole process. They kind of orchestrate all the other components. But yeah, so the CI tool will pull source control and listen for changes to our code base. And then when a relevant change is detected, it kicks off the rest of the process. So next comes the build agent. The build agent is kind of the guy that does all the work. He's going to be the system which actually executes the build process. If you have automated tests, they would be executed here as well, typically. But these are often called jobs. Just the act of building, of running the automated tests, it's called a job. And the CI tool will instruct the build agent to run the job on those latest and greatest code changes. So in another way, just kind of an aside on build agents, because it's an important piece. If you imagine an organization with like a lot of different software teams using a lot of different tech stacks, they might have several of these build agents, each having a different tool chain, running a different job specific to the app or the component of a whole application that they're responsible for building. So a lot of times these build agents can just be like transient containers or virtual machines that are sort of spooled up on demand by the CI server. Then they complete their build task and then they clean themselves up. They upload the artifact and clean themselves up. So yeah, in our case, using TwinCAT, the build agent would be a PC or maybe a virtual machine running the development environment and those automation scripts. So the build agent receives the current version of the project, performs the build, maybe runs some tests, then reports back the results of the build output, often called an artifact, to the CI server. So typically the CI tools provide a nice graphical interface for visualizing the results of the job as well. But then it stores that artifact for deployment. So the last piece is rolling out those artifacts to any of the targets that need the updated code change. And this is the typical flow, but because we're dealing with PLCs, we might have a unique situation where we connect directly to the controller from the build agent. And if it's a small change, maybe we just perform an online change instead of a full download. Or maybe it's advantageous to connect directly to the controller and make that update from here instead of just pushing it out as a file. But the important part is both are feasible with TwinCAT and with the automation interface. So hopefully that kind of clarifies this process at least a little bit by breaking it down into all the different components and their roles. Do keep in mind, though, this is totally scalable, right? We can have multiple repositories or multiple branches in our repository that kick off different jobs in different build agents based on what needs to be updated, based on what code changes were made. So everything is just very flexible and very scalable. All right, and now we briefly touched on testing in that last bit, but there might be a handful of you that are particularly interested in that topic, so we can explore that a little further as well. And none of us are strangers to comprehensive testing of our PLC programs. But for most of us, this is a very manual process, right? Flip this bit, see what happens. Did it work? No, okay. Add some variables to your watch window or maybe a YT chart to see it change over time, make some tweaks, reset everything, and try again. And some level of this manual functional testing is always going to be required, right? Especially in our industry, we are device level programmers. We have physical representations of our logic. It needs to be right. However, none of this disqualifies our ability to leverage automated software testing, for example, unit tests, right in the PLC. This is especially true if we've already taken the first step in adopted object-oriented programming, because we're all experts now. Right, our code modules are encapsulated and loosely coupled with other components in the system. That means they don't rely on each other. So ideally, we can test their functionality individually in isolation, right? Then every unit of code that we're able to verify ahead of time with automated tests, it's one less thing we have to worry about later on developing our application. These tests also provide a level of documentation by clearly outlining the intended behavior, right? For this input, I expect this output. And finally, they catch and prevent regressions or modifications made in the future that might break things that previously worked. So what might that look like in a PLC, right? We don't have, in the automation industry, we don't have countless frameworks and libraries specific to testing like our software friends, right? They've been doing this for years. They have mature tooling that's well integrated with the development environments. It's integrated with the pipelines. It's all very well established. We do, however, have this open, flexible PC-based platform, and it gives us multiple avenues for implementing automated tests. So some users end up rolling their own functions or libraries, like we're going to see here in a minute. But also there's several open source offerings as well. So I'm just searching GitHub here for TwinCAT unit test. And many of these have become quite popular. So huge shout out to those contributors. I always appreciate seeing high quality community driven content. And some of these options even have instructions or tooling for testing within the CI pipelines. So they give you instructions on how to integrate their test framework with the tools that we talked about before with your Jenkins or your Azure DevOps. So while this may be brand new to many of you, it's certainly not at all uncharted territory. So, and we have a quick demo of this in action as well. And I'm going to show you a video here illustrating the Jenkins continuous integration tool with a full build and test pipeline. So we're going to see the whole thing from making a code change to getting an artifact. And we're also going to do some automated test execution within the TwinCAT runtime. So like we said, it starts with a team member making a contribution. So here I am in the interface again. I've made some code change, and I'm just going to commit that change and push it to the repository. Then we're going to switch over to the Jenkins interface, and we have a job set up here called TC build. And I'm just going to pause it real quick. We're going to see that it's polling source control. So it saw that change. It has a pending job here. So we can actually click on that instance of a pending job running in the pipeline. We can actually watch that happen in real time, right? The build agent is the one that's actually executing this, but it's feeding all the results back up to the CI server. So it's going to run through, it's going to run our automation script, our automation interface script. It's going to run some tests, and then it's going to share those test results with Jenkins. And we'll be able to see that too. It looks like everything was happy. So we go back to our main page here, and we have all the test results here, and we can kind of drill in and see all the tests passed. And now this sample uses a very rudimentary PLC test library to compare or assert input data against some expected value, right? This is a pretty standard unit testing function. But Jenkins then simply needs the results of those assertions formatted in a specific way, and it's just an XML file, so that they can be viewed like this in the Jenkins interface, viewed and analyzed. But luckily, TwinCAT has plenty of XML functions to simplify this piece, right? It's not too bad. So yeah, we're just clicking around, viewing the test results. I can go back and actually look at the build artifacts as well. Here's what was published. Again, it's just that boot directory, but we have the TwinCAT runtime that we could then freely distribute. And then I'm just going to go through and click on an older failed test. And I can see exactly which one failed. You can see it's marked as a regression because this test was one that had previously passed and now it's failing. So you have all of this feedback right within the CI tool. Again, it kind of ties everything together. We also have the ratio of pass to fail tests over time, just a nice visualization there. So that's just one quick example, but there's actually an alternative approach to testing that I like to illustrate as well for a couple different reasons. One, it highlights another advantageous Beckhoff technology. That's our application protocol called ADS. And two, it can leverage those more mature testing tools available at the higher level software languages, right? So this can benefit you if you have some experience, you have reps with some of those software testing tools. You might not have to reinvent the wheel thanks to ADS. So ADS would typically be your protocol, your vehicle for exchanging data with a TwinCAT PLC from, for instance, some custom app. Maybe you wrote your own .NET HMI or something. ADS would be how you retrieve your tag data from the PLC runtime. But it's a totally open protocol. So in addition to our Beckhoff's officially maintained APIs in C++, in .NET, and Java, there's also several community developed implementations in just about any software language you can think, right? There's a Python version, Golang, Node.js, a bunch of them. And again, huge shout out to those contributors. But in addition to simply being able to read and write PLC data, We also have full exposure to the PLC's type system. We can interact with complex data structures. We can even issue remote procedure calls. So perhaps we can use ADS along with our familiar test environments. So maybe we can reach in from some external system using ADS and query for all function blocks which implement the iTest interface. Or maybe they inherit from some base type function block that we want to query for. Or even something simple like they're a function block that has the underscore test suffix in their name. Right? TwinCAT would then be able to return all instances that match that query. And then we can go through and, in this case, since maybe they all implement the same interface, we know they have an execute method. So we can trigger it via remote procedure call and then collect the results. So this is just another option. Again, if you want to employ those more mature and powerful test frameworks in your language of choice. And sometimes this gives you some added benefits. It might be easier to stand up mock data. Maybe it's cleaner to call the test methods externally like this. Versus having to explicitly call them from within the PLC. And again, a lot of these software test frameworks just work out of the box with the CI tooling or with your development environment. So you kind of skip that you skip that piece of having to manually format the test output so that the CI tooling can digest it. And actually we have a small example of this running as well, and we're using a different CI tool here. Maybe some of you recognize this, but this is Azure DevOps. So this one is using Azure DevOps, or ADO for short, TwinCAT with automation interface, and a .NET app to trigger the tests via ADS. So ADO Azure DevOps is really nice because all the DevOps tools are in the same place, right? You have the repository here, you have all the pipeline configuration, and you even have your boards. These are like where you can make a work item for instance, a bug fix or a feature request. And then you can relate that to its associated code change and build artifacts. So you can assign it to team members. So it's just even more context to the changes or modifications to your program over time. So I just click around through the Azure DevOps interface a little bit here, and then I'm going to go back to the development environment. Again, it starts with a team member contributing to the code base. But you're going to see a lot of the kind of same workflow with just a different skin, right? We go through, we see a new commit. Again, we have a little bit more information here because the repository actually lives within Azure DevOps, but we see that kicked off the pipeline execution. So we can click in, and the same with Jenkins, we can watch that job execute in real time. We can watch the feedback from the automation interface script that runs. And then you can see it's also doing a .NET Core CLI. It's triggering the tests in the C# XUnit test project. And the advantage there is, again, I get to use the Test Explorer within Visual Studio. And because it's C#, because they're all Microsoft technologies, Azure DevOps just knows what to do with those results. I don't have to do any extra work. I don't have to format anything. You can see all my tests pass here. I have this nice interface for browsing the tests. I have some additional metrics here that just automatically came in, like how long all the tests took to execute or each test. And they even send me a nice little email with a summary of that pipeline process. So again, just another option. So you've now seen two CI tools in action and kind of two separate approaches to automated testing and all the accommodating technologies. So both Beckhoff and third party. And now before wrapping up this phase, we've talked about automated testing, but I also wanted to touch on kind of engineering systems testing in general, right? There's this whole conversation to be had about device emulation, about digital twins, virtual commissioning, another hot topic. And even though I consider those to be a little outside the scope of the DevOps topic we're talking about today, I don't want to exclude it entirely because it is relevant, and also because Beckhoff has a lot to offer in this space as well. Right, so we can integrate with CAD tools like what you're seeing here with SolidWorks. We have a long-standing relationship and tight integration with MATLAB and Simulink. So if you're familiar with those tools, right, you can run a MATLAB or Simulink model. It could be executed synchronously from right within TwinCAT. And then finally, we have compatibility with many other third-party simulation tools, whether that's via the functional mockup interface, a standardized kind of simulation format, or the aforementioned ADS protocol that we already talked about, which we've recently actually seen customers utilizing with tools like Unity or NVIDIA's Omniverse, right? It's an open driver to communicate with TwinCAT, so lots of avenues there. Anyway, if you're particularly interested in these capabilities, feel free to reach out to me or to your local Beckhoff resource, and we could dive deeper in on that. But we are going to keep going and head into the final stage, which is maintenance. Hopefully, many of you already know about the myriad of connectivity options Beckhoff offers for monitoring and acquisition, right? Whether it's OT protocols that we're all familiar with, like EIP, Profinet, of course, EtherCAT, or IT protocols like MQTT, like HTTP, or even direct database connections, right? All of these can be realized right from the controller without any bridge device or any third-party software. So you combine that with a web-based HMI, you can leverage those things to monitor both the state of the PLC itself, as well as the application or process it's running at any time from anywhere. So this video just shows off some quick HMI features like diagnostic controls, the event system. Here's our EtherCAT diagnostics control, just really cool stuff. This demo is actually publicly accessible as well. So via cmi.beckoffcloud.com, and I'll have a link later on. But I encourage you guys to check that out, click around and explore more features there. But finally, we offer a full-scale analytics solution, which encompasses basically the entire data analysis workflow, all the way from acquisition to dashboards. So from the maintenance perspective, we're really just bringing the broad capability of connecting and sharing information with basically any kind of external system. And then on the application side, we've recently been seeing a ton of opportunities to utilize the IT connectivity capabilities. And this is another kind of sidebar, but also relevant to kind of the maintenance phase from the connectivity perspective. Just being able to serialize or deserialize JSON right in the PLC code with a single method call, right? And then send or receive that via HTTP or MQTT, again, with no additional hardware, no software, just opens up a lot of avenues. So we see customers leveraging push notification services, like to send alerts, calls, emails, text messages for machine status or faults. We see the utilization of HTTPS and authentication services, so you can securely transfer sensitive information from either a web, a cloud, or an on-prem endpoint, or just publishing messages to any upstream service, right? MES, ERP, warehouse management systems, you name it, we could talk to it. So that's really the value that we bring from the maintain perspective, is just that having access to all the data all the time. So, I mean, there it is, the full software development lifecycle and all the relevant components. And that's basically the enablement of this workflow in the industrial automation space. So that wraps up my presentation for today for the most part. I know we covered a ton of high-level topics here. Thank you all for your time, for your patience. I know it gets a little crazy with abbreviations and acronyms and all the concepts and terminology, but hopefully you've learned something new, maybe gained some insight into what's possible with a more forward-thinking automation platform. So we're going to end. We got, good. We got about 15 minutes for some open Q&A. So there's a little question area right in the go-to interface. If you haven't found that, that's where you can enter your question. I'll also keep an eye on the chat section for the next few minutes. I did have a few that came in throughout the show. The first one here is, do you need a Visual Studio license to do this? And based on when it came in, this I think means the pipeline automation or the automation tasks in general. And this is a good opportunity to kind of clarify the difference between Beckhoff's engineering XAE shell, we call it, and then full Visual Studio. The short answer is no, you don't need a Visual Studio license to do any of this. You don't even need full Visual Studio. Now, our development environment is based on Visual Studio, but it doesn't have all like the C# language tools, the ASP stuff. It's just, it still has the source control integration. It still will allow you to do all the cool automation stuff that we saw. But it's just the shell with the TwinCAT tooling on top of that. Let me see what else we have for Q&A. I don't have any assignments yet. Okay, let's see. Looks like I got some over here. Is the documentation tool compatible with Sphinx or restructured text markup language? That I cannot speak to, unfortunately. I've not used restructured text. I've heard a lot about it. I know that it has a lot of traction behind it. I assume yes, unless Restructured text is specifically looking for a certain comment syntax as well. Maybe they might overlap with each other, but it's just in the comments section. So as long as they're not going to interfere, then I assume compatibility. Concerning Jenkins automation, is there a way to simulate hardware I/O? Yes. So we do have a EtherCAT simulation product as well. So this is kind of a loaded question, but it kind of goes along with, can you use simulations, or can you use device emulation or digital twins in your automated testing? Yes, totally within the realm of possibility. Obviously, it would require, depending on what simulation tools you're using, you could very conceivably have a second TwinCAT project in its own pipeline that's just the emulation. So if you were using our EtherCAT simulation, then you would have sort of the same process image, but all your inputs would be flipped to outputs and vice versa, right? But you could keep that in a separate pipeline, and then you have your simulation logic and your application logic, and maybe they have some shared resources in a library or something, and that could even have its own pipeline so that all the versions are synchronized and everything. Totally within the realm of possibility. It's a great question, but yeah, obviously requires more consideration, a more sophisticated build script, maybe a beefier build agent to facilitate running multiple real times, but yes, definitely possible. All right, let me see. Can you open TC compare, comparing an old Git commit as opposed to just comparing? So actually, yes, because TwinCAT compare can actually work as a standalone piece as well. So you can actually just point to two different project files. So you can work with both versions that are in source control and also just static files. So it can point to two different projects, or it has the source control integration like we saw in the demo. Yeah, and I'd be happy to help you out with that as well, kind of just setting that up or exploring more of the features with that tool, but it's pretty flexible. Forget which port of solution is checked into Git, entire solution including build or just the logic part. No, so there are, if you just search online for like a TwinCAT 3 Git ignore file, it will ignore all of the build output, all of the stuff that you don't need, like all the metadata and stuff, and only keep your code. So, I mean, you can opt to keep the binaries and all the build output with your version control as well, but there is a well-established git ignore file out there that most everyone uses for source control. With ADO, if we need to deploy one solution to multiple targets, how to differentiate to different targets, especially their unique IDs of Ethernet adapters. If those are checked into ADO, then every time we compile, it changes from target to target. Yes, so we have a couple different approaches to doing that. We have a variant manager that would allow different target configurations. You can have different branches for different targets, although I don't think that's an ideal solution. I might have to noodle on that one. Absolutely doable. I just have to think of what the best mechanism for achieving that is. But yes, we see that all the time. Again, it's really flexible. So I encourage you to reach out to me offline. I have all of these captured, so I can follow up later on, but I'll also close with like my email and encourage anyone to reach out. Let's see, is the documentation okay, got that one. Is TC3 compatible with pipelines in Atlassian or Bitbucket? Again, a lot of these things kind of work the same way. So yes, it might look a little bit differently, but it's totally doable. So when searching on the web, Jenkins is the most common recommended CI/CD tool to use with TwinCAT. Is that due to cost, open source availability? Probably partly. Or is Jenkins the closest plug and play? It sounds like Azure DevOps can be used as well. Yep, we saw that. Yeah, so I think this was probably answered. So I think Jenkins might have been the first one that anyone implemented. First of all, because it was out before Azure DevOps was a thing, or before it was really popular. And also because it's free and open source, right? But again, and I stress this again, a lot of these things are really just doing the same thing. So as long as they can trigger, as long as they can pull your source control, whatever source control you're using, as long as they could trigger the execution of a command line script or a PowerShell script, or they can run like the .NET CLI to run a C# project, because you can do all that automation interface stuff in a .NET project as well. As long as it checks kind of those really rudimentary CI tooling boxes, then you can implement it. Now, the level of effort to get it working appropriately might be different from tool to tool, but it's totally doable. Okay, let's see what else we have here. And it looks like I have some help in the... Do you need a server space to run a build agent with your CI, or can something like Git help run this? So to run a build agent in both the tools that I illustrated today, the build agent was literally just an IPC sitting in my office. So whether that's Azure DevOps running on the cloud, or a Jenkins instance even running on the same piece of hardware, we don't really care what the build agent is, as long as it can communicate with the CI tool and it can run the scripts that we need it to run, right? So for instance, when you're setting up both Azure DevOps or Jenkins, they actually spit out a script based on what platform you're using. They spit out a script that you would run on the build agent, and the build agent would then need network access to be able to contact that CI server. But it spits out a script. You run the script on the build agent, and that establishes the connection between the build agent and between the CI tool. And so they can communicate with each other. The CI server can tell the build agent, it can execute tasks on there. So yeah, that's typically kind of the easy part, is getting the build agent configured. And again, this is really flexible from an architecture perspective. So I've ran this in instances, and I've kind of put together tutorials where all of this was on the same piece of hardware. So even the Git repository, the remote repository, the CI server, the build agent instance was all running on the same piece of hardware, just for like a demonstration purpose. So the kind of discrete components can be on different pieces of hardware. They could be on the same hardware. It's really flexible from an architecture perspective. All right, so someone who is on a very tight schedule and doesn't have time to use test-driven development, are there easier ways to set this up in a short time frame? Yeah, there's. I mean, you called out TC Unit there. That's a great resource, and again, the writer of TC Unit provides documentation on how to integrate that with a CI pipeline as well. So that is, all those resources are available to you if you don't want to kind of write your own test framework. And now test-driven development is kind of a loaded term as well. Right, again, we're all familiar with testing our logic, but kind of thinking about writing code in a manner that's testable is like a totally different way to write software. And you know, it can be argued whether or not that's the correct way to write software, but you can still leverage and take advantage of unit tests without going full test-driven development. Again, a unit test in its base form is just asserting that some expected output matches, or some expected value matches, you know, some input. So you could still take advantage of automated tests without going full on TDD. Let's see if I can, what are the... Can automation interface be used to update safety PLCs? So safety is kind of another question there. We do have a safety loader component for automating some of the safety work, but there is not at least to my knowledge, a current way to actually automate like starting up and running a safety project and executing the logic in a testable manner like that. Sure, you can update the safety PLC logic, but you might not be able to actually execute it and update it on the target itself, because you have to put in that password. You have the cyclic redundancy check that you need to verify and everything. Will the unit test framework like TC Unit be part of the Beckhoff library? That's a good question. I don't see Beckhoff rolling out their own test framework because there's so many good community. There's so many different ways to do it, and there's so many good community resources. That being said, I wouldn't totally rule it out. All right, can we export VFD servo parameters in Excel CSV format? Yeah, I don't see why not. So actually, you can export it for sure in XML. Like kind of behind the scenes, how automation interface is working is there's just a lot of XML. That's a lot of how the program configuration interface in TwinCAT works. So you can do it in XML. You would have to write additional logic to maybe parse that XML and then convert it to a CSV or some character separated format that you're looking to target. But with that automation interface tool, with the ability to export all your configurations in plain text, there's very little that you can't do, right? So I would say, yeah, it's definitely absolutely in the realm of possibility. How are the cybersecurity measures? Does TwinCAT have capabilities to restrict the people from opening the project depending on the users who are approved under the controls engineering? So this is, again, kind of a loaded question, but it goes back to being PC-based controls. So you can restrict both based on the operating system, and you can protect the source code itself. So there's a couple different avenues for like OEM code protection, and also protecting access to the device, the target device itself. And I see a lot more questions, tons of questions. These are all really good questions, and I wish I could get them. We are going to get cut off at the hour mark. I still have access to these questions, and if you guys, again, I encourage any of you to reach out to me directly. I'm Brandon, b.stifler@beckhoff.com. And then if you'd like to learn more, just feel free to reach out to me or your local Beckhoff representative. Right on the page, you see the two QR screens. One is for the webinar series registration for future sessions. The other is a contact us form. And I also have some other web links there, our Infosys page, and then that HMI demo. But there will be a follow-up email to all the registrants that you can use for any additional questions. And again, I very much appreciate everyone's time today.